Today we'll talk about another feature called Smart Scan, which is also called as offloading. Perhaps this is one of the most impressive and important feature of Exadata. So let us see Smart Scan. Smart Scan moves a part of SQL processing from database servers to storage servers. Smart Scan reduces CPU usage on database servers. Smart Scan dramatically reduces the volume of data sent to database tier, thereby improving query performance. So these are all the statements related to Smart Scan. Okay, so to understand this, let us see one example first. What is Smart Scan and how that is useful. So if you take non-Exadata systems, okay, the traditional systems, and see the I/O processing. Okay, now here you have client, you have database server, you have storage. Follow my mouse, observe my mouse. So this is the client machine, this is the database server, and this is the storage layer. Now data is on the storage. Now a client application issues a statement, select statement like this. So here the intention is I want to see customers, okay, whose order amount is about 20,000. Okay, big customers. So this kind of query does full table scan, right? Because it has to scan every record of the table and see the order amount. So when suppose this table is very big, say this table is 10 GB in size. How this processing happens now? So the client issues the select statement to the database server. Database server identifies the extents of this table and issues I/O request to the storage. And the I/O is executed by the storage layer, and it identifies 10 GB of data because it is doing full table scan. So now this 10 GB is returned to the database server, where the predicate is evaluated, the where condition is evaluated, the block processing is done. So out of this 10 GB data, only 2 MB matches this query condition, where clause condition. So this 2 MB is returned to the client. Okay. So this is what happens in traditional SQL processing. Okay. So here what is happening? The storage layer is sending all the blocks of the table. Okay. Because the block processing is done by the database server. Database server has the intelligence. Storage is a dumb storage, right? Traditionally we are using dumb storage. So storage simply sends the block to the database server. Inside block what is there? How to evaluate that? Storage doesn't know that. The database server does that processing. So that way the storage is sending 10 GB data to the database server. So this 10 GB consumes the network bandwidth, right? And the 10 GB transmission takes more time, right? So that way your query performance is not optimal here. And out of 10 GB, after SQL processing, only 2 MB is the matching data. So that means the remaining data is discarded by the database server. Okay. So in this way, you are unnecessarily wasting lot of system resources. And obviously your I/O performance is poor. Now, let us see the same thing on Exadata using Smart Scan. Again, the same client, same database server, and here you have Exadata storage. Exadata storage is intelligent, right? It is not dumb like other storage servers. Now the client issues the same statement. Now on Exadata, database servers construct an IDB message and send this message to Exadata storage servers. Now SQL processing happens inside the storage server. Okay, instead of sending the blocks directly to the database server, storage server process your SQL statement. The where clause will be evaluated inside the storage server, and the storage server opens every block, reads those matching rows and matching columns, and send those matching rows and matching columns only to the database server instead of transmitting the entire block. Okay, so that means the block processing, the data filtering is happening inside the storage server itself, because the storage server is Oracle storage server. Oracle storage server can understand Oracle database block format. Other storage servers cannot understand Oracle database block format. Okay, so that way Oracle Exadata storage server can open the block, process the SQL statement, identify the matching rows and matching columns, and send only those matching rows and matching columns to the database server instead of sending entire block. Okay, so because the SQL processing is happening at the storage servers itself, ultimately the matching data size is 2 MB. So only the 2 MB data is written to the database servers instead of sending the 10 GB worth data, because 2 MB is transmitted to the private internet, private interconnect. It can transmit in a very quick fashion, right? And that way your I/O performance is much better with the smart scan. Okay, so in this fashion, what is happening? The SQL processing is offloaded to the storage server. That's why this feature is also called offloading. And because the processing is split between database server and the storage server, you are using CPUs on both the servers effectively. Instead of in the traditional processing, the CPUs on the database servers are used for complete processing. Here you are distributing the processing between database servers and storage servers. So that is, now you look at these statements, you will be able to understand better now. Moves part of smart scan moves part of SQL processing from database tier to storage tier. Reduces CPU usage on the database tier. Dramatically reduces the volume of data sent to database tier, thereby improving query performance. Okay. So that is the concept of smart scan. Doubts? Concept is understood?
Yeah. So, Murali, this is Velu.
Yeah.
So, I mean, this is like a directly proportional to the size of the blocks, or like normally, like the size of the blocks, we normally go with the 8 MB, right? 8 MB size, block size, right?
8 KB.
Oh, sorry, 8 KB block size actually.
Yeah.
So, with that said, actually, like, I mean, the proportionate of data to the blocks will not be like way too different, right? I'm just trying to visualize because the amount of data needed to the data block size actually.
No, ultimately, how much data? No, it's not block size actually. More than block size. How much data is matching with the query condition? Okay.
Okay.
So that is what decides your query performance. See, you are reading a big table, 10 GB
Okay.
table, but ultimately you need 2 MB data, a fraction of
Okay.
that table. So in that case, you see dramatic performance improvements. Traditionally,
Okay.
the entire 10 GB will be returned to database servers.
Okay.
But on Exadata, 2 MB will be returned. Only the matching data will be returned to the database servers.
So I'm just again trying to understand. So like for example, we have like a like data warehouse servers like that, where tables can even exceed 2 terabytes of size, right?
Yeah.
So how the data will be read actually? I mean, it will be read in chunks and then processed and then discarded and then read in chunks and then processed and discarded. Is that the way normally the data warehouse reading happens?
You are talking about full table scan?
No, any size. I mean, even for the index scan, we might have to what to say, scan a lot of data and then only part of the data will be returned, right?
Yeah.
But say let's say the size of the memory is around 200 GB and the table size is 1 terabyte. And even to process the table, and I mean even with the indexes, and to process this table and then bring it to the memory and then process and then it will discard, right? Only keep those necessary data in memory and then we'll discard the rest of the data. Is that what will happen?
Yeah. I think your question is general question, not related to Exadata. Yeah,
No.
that is.
I'm just trying to compare actually. I mean, is that what happens in the, so that is that what happens in normal servers, so that
Correct.
Exadata is like very much powerful. That's why I'm trying to correlate actually.
Yeah, on non-Exadata, whatever you said is true. Data will be read, presented to client and discarded. New data will be read, presented to client and discarded. So continuously, the buffers will be reused inside the buffer cache.
Oh, okay.
It's like a water entering through pipe and exiting. New water enters and exits. So continuously, it has to read into blocks, right, and discard those blocks again by loading new blocks. But when you use Exadata, this is not required because the block scanning, data filtering is happening at the database storage server level. Okay. Yeah. If the query is using Smart Scan. If the query is not using Smart Scan, the traditional approach is still used inside Exadata also. Okay.
So is Smart Scan is like a licensed thing, or it is available for free for any Exadata service?
No, it is a part of Exadata. It is standard feature of Exadata. No license required.
And what is the init parameter, or what is the parameter needed to ensure that it is on?
Yeah, there are some conditions for that. We'll discuss over the next few slides.
Okay, yeah, thanks.
So at this stage, have you understood the concept of Smart Scan? That is what is important. Then we will see more details about Smart Scan.
Yeah, I understood the concept actually.
Yeah. Okay. Any more questions from anybody? Concept is clear. How it is different from your traditional scan? Okay. So then let us move forward. Smart Scan includes few things. Smart Scans, okay, include table and index scans. Where it is table scan or even index scans also, use smart scans. Okay. So smart scans are performed inside Exadata storage server rather than transporting all the data to the database server. Then smart scan uses predicate filtering. Predicate filtering is nothing but only the requested rows are returned to the database server rather than all the rows in the table. Column filtering. Only the requested columns are returned to the database server rather than all the columns of the table. So only the matching rows and exactly the matching columns will be returned to the database server. So that way the data transmitted to the data server is exactly what is required by the database server. No more, no less. What you need, exactly that. Remaining all filtered at storage server level itself. Smart scan requirements. As I told you, smart scan, traditional scan, both are used in Exadata. And smart scan has some requirements. These are the requirements. Smart scan is possible only for full table or full index scans. Smart scan can only be used for direct path reads. What is direct path read? Which doesn't use your traditional SQL processing and buffer cache, right? So direct path reads read the data directly into the PGA of the server process bypassing the buffer cache. Direct path reads are used by parallel operations. So any parallel query is automatically uses smart scan. And there are some additional requirements. Inside the database, there are some parameters which you need to set. The parameter is cell offload processing should be set to true. Otherwise, smart scan will not be used for that database. So that way you have the choice to switch on, switch off this feature, okay, inside the database. Even though it is enabled as a whole, you can control at a database level. Cell offload processing must be true. Then only smart scan will be used for that database. And this parameter, okay, can be controlled at a statement level or session level or system level. Okay, at session level, system level, you can use alter session, alter system command, and this is a dynamic parameter. So you can use alter system or alter session. And even at the statement level, per statement, you can control using hint. There is one hint opt param. Okay, so you see the statement select opt param, that is the hint. Cell offload processing false. Okay, so that means for this query, smart scan will not be used. Even though it is enabled for this query, you are hinting that smart scan should not be used. So that way you can control at statement level using opt param hint, then session level using alter session, and system level using alter system. And there is another parameter. Whenever smart scan is performed, the execution plan will show you the smart scan related operations. So if you want to display, okay, offloaded predicates in the execution plan, you should set these parameters to cell offload plan display, okay, to always or auto or never, okay. But this will not control whether smart scan is used or not. This will show you the predicates that are offloaded to storage server in the execution plans. Then other requirements are the segment data must be stored in disk groups that are completely stored on Exadata cells. Okay, so the data must be on the Exadata storage. Otherwise, this feature Smart Scan will not work. If you are using non-Exadata storage, you cannot utilize Smart Scan feature. Then next requirement is the ASM disk group that stores the segment data must have these attributes set. Compatible attributes 11.2 minimum, and cell.smartscan capable must be set to true. Okay, so these are the conditions for Smart Scan. If any of these conditions are not met, the Smart Scan will not be used. Instead, the traditional block scan, the traditional scan will be used. And for a single statement, for a statement, Exadata may use both the scans. Some blocks may be accessed using Smart Scan. Some blocks may be accessed using traditional scan. So a mix of both the scans can be done for the same statement. Okay, so these are the points related to Smart Scan. Next, Smart Scan cannot be used under the following conditions. This slide shows you the conditions that prevent a Smart Scan. Okay, so there are few conditions that prevent a Smart Scan. Few things to scan on a clustered table. If the table is a clustered table, Smart Scan cannot be used. Scan on index organized table. If the table is an IoT, Smart Scan cannot be used. Okay. Fast full scan on a compressed index. Fast full scan on a reverse key index. Table has row level dependency tracking enabled. So like that, there are few conditions which prevents the Smart Scan. Like some important ones, lob or long column is being selected or queried. More than 250 columns are referenced in the query. Okay. To evaluate a predicate based on a virtual column. So like this, there are some conditions that prevent Smart Scan. So if these conditions are present, if these conditions are met, it uses the traditional scan, not the Smart Scan. Again, whenever Smart Scan is possible, the execution plan indicates that. You see this? This is the execution plan for a query. In the execution plan, you will see storage clause. Observe this blue line and storage. So storage clause indicates that this query is eligible for Smart Scan. Okay, but whether Smart Scan is really used or not is different. Okay, so looking storage clause inside the execution plan doesn't guarantee you that Smart Scan is used in reality. Okay, Smart Scan is possible, but whether Smart Scan is really used or traditional scan is used, okay, should be verified using statistics. There are statistics related to Smart Scan. So looking at the statistics only, you can tell whether Smart Scan is used really or traditional scan is used. Plan is just a plan, right? So at runtime, the plan may be followed or not. So this is the tested. Seeing storage in the execution plan does not guarantee that the query is satisfied using Smart Scan alone. Okay. For example, if the Exadata storage server is not sure that the block is current, okay, it transfers the block read to the buffer cache. It will not use the smart scan. For example, the essence of this point is, if a read consistent version of the query is required, a read consistent version of the block is required, okay, the entire block will be shipped to the database server. Database server has to construct the read consistent version of the query. So in this case, smart scan will not be performed on the block. Instead, the entire block will be transferred to the database server. That is, then if chained rows or migrated rows are detected, again smart scan will not be performed on that block. Instead, entire block will be sent to the database server. Then another interesting point is, an intelligent feature is, if Exadata storage server CPU utilization is significantly greater than the CPU utilization on the database server, then smart scan will not be performed on the blocks. Instead, the entire block will be transmitted to the database server, and the database server has to filter the blocks now. Okay. If all the required data is already in the buffer cache, then there is no IO required, no smart scan required. This is common sense point. If the block is already present in the buffer cache on the database servers, there is no IO required for that, whether it is traditional IO or smart scan IO. Okay. And finally, statistics and weight events can be used to confirm whether smart scan is really done or traditional scan is done. Okay. So these are some more points related to smart scan. So just looking at the storage clause in the execution plan, you cannot tell this query has used a smart scan. You have to use the statistics. Then only you can confirm 100% that it has used a smart scan. And the storage clause is shown, and the predicates that are offloaded to the storage server are also shown in the execution plan. So in this, what is the where condition? Explain plan for select count star from customers where cust valid equal to A. So this predicate, this where clause will be offloaded to the storage server. So that is being shown in your execution plans. Now some examples. This will show you the smart scan operation. Again, for indexes also. Index, it is using smart scan for index. Index storage fast full scan. What index it is going to use? Customers underscore PK. So on that index, for that index scan, it is saying that smart scan is possible. Then this particular execution plan doesn't show any smart scan operations. Why? Because this query is on an index organized table. For index organized table, smart scan will not be used. So that way, there is no smart scan related operations shown in the execution plan. Then these are the smart scan optimization. There are some other smart scan optimizations available. Let us see what are those. Compression, decompression, right? Compression is always done at the database tier only. Decompression of data stored in HCC format during smart scan operations is offloaded to cell server. So Exadata uses a new compression algorithm, a new compression technology called HCC, hybrid columnar compression, which we will discuss, okay, if time permits in today's class, otherwise in tomorrow's class. So if data is compressed in HCC format, the decompression can be offloaded to storage server. Only the data that will be returned to the database tier will be decompressed. Decompression may also be done at a database tier when data is not accessed via smart scan or when the storage server CPUs are busy. Okay, so in essence, on Exadata, compression can happen at a database tier, decompression can happen at storage tier. Traditionally, compression, decompression both happens at database tier. So that way, decompression can be offloaded to storage servers utilizing the CPUs on the storage servers. Similarly, encryption, decryption. Traditionally, encryption, decryption both happens at the database tier. On Exadata, encryption always done at database servers. Decryption can be offloaded to cells or database servers itself. When encrypted data is accessed via smart scan, it is decrypted on the cells. Otherwise, it is decrypted on the database servers. So, smart scan internally uses decompression and decryption on the storage server itself as required. Then virtual columns. Virtual columns provide the ability to define pseudo columns that can be calculated from other columns, without actually storing the calculated columns, calculated values. So virtual column is computed based on the actual columns. Suppose you have salary column, commission column. I want a total salary. Total salary is salary plus commission, which is computed on the fly, because normalized tables doesn't store totals, right? So that is called a pseudo column. Total salary, which is salary plus commission, is pseudo column. So in this case, these virtual columns must be calculated on the fly when they are accessed. On Exadata, these calculations can be offloaded to storage servers via smart scan. So traditionally, for evaluation of the virtual columns, for calculation of the virtual columns, database tiers will be doing that. But on Exadata, these calculations can be offloaded to storage server. So these are some of the smart scan related optimizations. Then there are some other non-smart scan optimizations, available on Exadata. One is smart file creation or fast file creation. Second is, on Exadata, RMAN incremental backup performance can be further improved. Then on Exadata platform, RMAN restored, is better. The performance is much better on Exadata platform because of improved algorithms used on Exadata. So these algorithms will be used when the underlying storage is Exadata storage. Otherwise, they are not invoked. So let us see what is this smart or fast file creation. See, whenever you create a data file on Exadata, the creation is little bit faster compared to non-Exadata storage, because the block formatting is done by the storage servers. Whenever a file is created, the blocks has to be formatted in Oracle format, right? So for that, the storage will send the block to database server. The database server will format the block and again write it back to the disk. So that way, when a file creation is happening, there is I/O between storage and database tile. But on Exadata, the block formatting is done at storage server level itself. So that means there is no I/O between database server and the storage server during file creation. So this will add to your performance. Not only file creation, whenever you adding a new file to existing table space or extending the file, existing file. So all these operations will be quicker on Exadata. Then ARM and incremental backup performance are faster on Exadata. Exadata speeds up incremental backups by increasing the granularity of the block change tracking. I/O for incremental backups is efficient because only the changed blocks and the changed rows are written to the database server. Inside the changed block, okay, only the changed rows actually are written to the database servers. Okay, so that way you see further improvements with incremental backups. Then finally ARM and restores. So for restoring the data files using ARM, Exadata uses the CPUs of the storage servers. Okay, so that way you get better performance. So these are some of the non-smart scan related optimizations. Whether smart scan is used or not, these are always present on Exadata. So this is the concept related to smart scan feature. Questions?
So Murali, this is Velu. And will there be any what will be the overhead on the storage tier, and what is the kind of overhead will be there? Because anyway we are removing a little CPU overhead on the database tier.
Yeah.
So, but in that case, if we are moving that to storage tier, what will be the overhead on the storage tier?
Yeah, see that block processing is offloaded to storage server. See, if you see storage server, what is the general load on the storage server? I/O. If database is not doing I/O, there is not much load on the storage server. Storage servers are idle. If I/O is happening, then only storage servers are busy, right?
Yeah.
Okay, now you know storage server also has its own CPU, its own memory. They are also very huge, right? So lot of processing capacity is available on the storage server also. Instead of keeping this capacity unutilized or underutilized, you are better using for offloading feature. And again, offloading or smart scan is only for full table or full index scans.
Okay. So is this feature available in other Oracle storage servers apart from Exadata?
No. Smart scan is
I heard like a hybrid columnar compression is available in Oracle
correct.
Other storage servers.
Yes. See, so smart scan is only for Exadata.
Okay.
But HCC is available for other storages also apart from Exadata.
Okay.
Like Oracle has FS1 storage array. HCC is available on that. Oracle has pillar axiom storage. HCC is available on that. But smart scan is only available on Exadata.
Okay, thanks.
Yeah.
Murli?
Yeah.
You said that smart scan is not applicable for read consistent queries, right?
Read
consistent queries. If like you need a read consistent version, then smart scan is not applicable.
Yeah. That block, not the statement. See, if a block that is being read by the storage server is modified by another transaction now, right? So such a block will be sent to the database server, full block, instead of doing the smart scan on that. Because the rows have changed, storage server cannot construct a read consistent version of the block. That will be always done by the database server.
Okay, then it comes to the normal processing, like undo.
For that block. For that block. Other blocks may still use smart scan.
But we never know, right, Murli? Like in some companies, always like 24 hours, something or other reporting will be going on it when the read consistent version is required or when it is not required.
Yeah. No, you don't need to know that. It is transparent to the application, right? It is transparent to the application. You don't need to specifically know that. Okay. So if a block is changed while smart scan is happening, simultaneously smart scan is happening, and another transaction is modifying the same block, then only this situation will arise.
Yeah. Okay, thanks.
Yeah. Any more questions? Okay. So now the point is, this is what we discussed. When smart scan is giving better performance than index scan, why you want to maintain that index? Unnecessarily index consumes storage. Index needs maintenance, right? Any DMLs need to be applied to the index also. So there is overhead with index. So if a smart scan is giving better performance than index scan, you can drop such indexes in your application. So this is one of the important consideration during migration to Exadata. So you evaluate all the queries in your application with the smart scan, without a smart scan. Then see which one is giving better performance. If smart scan is giving better performance, then remove the indexes for that column used in that query. Okay. So in the lab also, we will be practically doing this. We have one hands-on where you evaluate a query performance with index, then with the smart scan. Then compare the performance and you can understand how we do in real time. Okay. So let me show you the hands-ons lab practices related to today's topic. 20. Observing smart scans using statistics. Okay. And examining smart scans through execution plans, statistics, and wait events. Then I told you concurrent transactions with the buffer cache flushing, concurrent transactions without a buffer cache flushing. This is that read consistent version and all that. We can practically verify that also in the lab. Then finally, testing the index elimination. With the smart scan, you may not need indexes. So there are 5 hands-ons related to smart scan feature. Please do all these things. Step by step is documented, and throughout these practices you will use various statistics and wait events. Okay, so tomorrow we'll see the remaining